Okay, so I think we can begin the meeting now. Okay, so hello everyone. I hope everyone is good today. So before I say anything, I just like to thank the SEG, UNAM, and UGSS for supporting this talk, along with Ms. Mary Barton, who is supporting us through Odika Investment CC. And so to begin, our speaker today is Sheron Kaviua, who has over 16 years of experience in the mining sector and is currently the Technical Services Manager and the understudy to the Vice President at Operations at Roshpina Zinc Corporation. Sheron is the founder and the president of the Future Leaders Association, and she was the first employee at the Langer Heinrich uranium mine and drilled out the resources from inferred to measured. She worked as an exploration, production, and resource geologist and was fortunate enough to take an exploration project through the mineral development phases to an operational mine. She joined the Trekkoper project as a resource geologist and drilled the resource to indicate and carried out mineral resource estimations. She held the position of a principal consultant before joining the Roshpina zinc mine as a senior production geologist and was later promoted, and she became the first female mineral resource manager in Namibia in 2016. She is currently pursuing a Master's of Business Admin with the London School of Business and Finance, and she holds a Master's and a postgraduate diploma in mining engineering with distinctions from the University of Wits. And additionally, she obtained her honors degree in geology from Rhodes University and a bachelor's degree in environmental biology and geology from the University of Namibia. She serves as a board member on the Roshpina Mine Pension Fund and Palmware Royalty and Streaming. And she was the Roshpina Woman of the Year in 2018 to 2019 and was the final best first-year student in 2004 at UNAM. And she was finally awarded the Top 10 Student Award at Veni Duplessis in 2000. So without further delay, I introduce Ms. Sheron Kaviua.
Thank you so much, Mr. Speaker. You know, it's really an honor for me to be here. Can everybody see my screen? Good afternoon, everyone. Must I share my screen or can everybody see the presentation already?
Oh, you have to share your screen.
All right, just a minute. There we go. Are we good now? Mr. Eno?
Yes, we can see it
All
very
right.
clearly.
So good afternoon, everyone. Thank you so much for showing up. It's a pleasure to talk to everyone present. So my topic today is what are the potential job opportunities for a geoscientist at a conventional mining operation in Namibia? So this may be an underground open pit operation, and as I'm presenting, I'm using either underground or open pit, but all these are interchangeable and just a few changes will need to be, I mean, if I say underground mapping, it applies to face mapping in an open pit. So thank you so much for the introduction. I'll just go through the topics that I'm going to cover. So I'll be very happy if I can leave here knowing that I've passed these 5 points through clearly to everyone. The first one is, how do geoscientists integrate with other sections? That's very important. So at a mine, we obviously do not work in silos. Where do we fit in within the value chain? So that is point number one that I'm going to cover. The next point is, what are the roles and responsibilities of the geosciences department at an active operational mine, or even an exploration project? And then thirdly, what is a typical career path for a geoscientist at a conventional mining operation? And what are the critical skills and knowledge required to perform well as a geoscientist at a mine? You see, this is very important because you can get into an operation, and if you do not acquire the right skill, that means that you will remain at that position for a very long time. And to avoid that, it's important that you identify these skills early enough, and I'm going to cover that. And lastly, with the introduction being shared, I'm just going to give some highlights on my career, which obviously was not mentioned within the introduction, and how long it took me during the different phases. And I'm hoping that I'll do the presentation and then allow some questions only at the end. That is just to make sure that we are within time. So how do geoscientists integrate with the other sections? Effective mining and mineral beneficiations are dependent upon functional integrated management practices in a wide range of disciplines, including geology, mining, mineral processing, financial management, and mining-related legislation. So geology does not work alone in silo. We depend on other sections. We are just the forefront, but and we carry out throughout the whole process, and we rely on other sections, and these are mainly mining, mineral processing, financial management, and mining related legislation. All right, and that brings us to the topic called mineral resource management. I just have got a technical problem that okay, I just need to move this up. Apologies for that. So that brings us to the topic called mineral resource management, which is an integrated management approach to the entire mining value chain that will lead to cost-effective and sustainable mining and mineral beneficiation practices. So important, the word integrated keeps on appearing time and again. But then there are three pillars of MRM. And historically, the department was called Geology Department. It's now common practice that it's called Mineral Resource Management, and it's mainly because of the integrated part of it. And we also belong to a bigger group, which those sections that I mentioned in some operation, all these sections are hosted together, and that department is called the Technical Services Department. So that is when you incorporate your mining, the survey, and the rest of the department. So back to the definition of MRM, as I've mentioned, that it's underpinned by three pillars. Pillar number one, it's the efficient resource identification and delineation process. So there is your pillar that hosts the exploration and the production geology, or exploration geologist and production geologist. And pillar number two is the optimal, economic, and safe. That is also very important. Safety is very key to a mining operation. So the optimal, economic, and safe planning to extract the reserve efficiently. Again, we then refer to mine planning section, survey, and geotech. And that's pillar number two of MRM. Pillar number three of MRM is the optimal recovery and concentrate grade. And this is where you start integrating with the plant. And this is a section called grade control. And you look at scheduling your resources and taking into consideration your mineralogy and the mixing or blending of your resources. So to highlight, geology is linked to other sections through an integrated management approach called MRM. And it's part of the mining value chain that would lead to cost effectiveness, sustainable mining, and mineral beneficiation. All right, so what is this MRM process? How does it look like? So imagine coming to a greenfield project. You've got zero information. What is the first thing that you would do? You would go and sample information. You would go and sample. So obviously you send the samples to the lab to determine its value. So it starts off with sampling and then the lab. And with the lab, you need to know whether the lab is giving you the results, the correct results. So at a very early stage, you already include your QA/QC, which is quality control, quality assurance. Quality assurance would be your standards that you insert within your grep samples or drill hole samples, and quality control is the procedures that you must have in place, how you insert or how you manage or ensure and control your quality of the information that you are gathering. So point number one is the sampling aspect and the analytical part of it. And then another input into this mineral resource process is your surface mapping. And already when you collect information at every step, you verify your data. So you can see that throughout your whole resource delineation or resource discovery, you need to verify the information that you collect. And after doing your surface mapping and grep sample, you will locate a regional target. Then there you've got regional exploration, doing regional resource location and definition. And once they are done, once they identify something that looks promising, they then give it over to local geologists or local exploration geologists or mine geologists, and they would do a local resource location and definition, further refining your resource by infill drilling and detail mapping and sampling as well. And then once again, that information that you get out of the local geology, if it's promising, you then proceed to resource delineation, which is closer spacing, drill information, and sampling information, sampling data. So those are then the three regional, local, and sometimes a mine geologist. Those are the three sections that takes care of that. But not only, so once you've reached the resource delineation phase, you then either decide to now open a test pit or go underground. And then already you start exposing some parts of your ore. So you do underground mapping. Now you've got all this information from your underground or pit mapping with your surface mapping, detailed drilling information and sampling. And these are your input into your MRM or into your resource modeling. And that information, you do not just put it in raw into your model. You first need to do data interpretation. So after you verified that the information that you collected are correct, you then interpret your information. So I should state that at this stage, the presentation for now, it's really theory-based. And then hopefully next time we can look at taking a certain deposit and visualize what I'm speaking about as a second stage of the presentation, a follow-up presentation on this. So after data interpretation, that your sections interpretation then goes into a resource model that you now estimate grades and tons. All this is still done by geologists. And then once you've got the resource model, which would now give you a tonnage and a grade over a certain area, that information is then given to the mine planners. Already here we are introducing mine planning, and you would see that the survey, the arrow at the bottom here, which is the survey department, it's throughout. You need accurate information, garbage in, garbage out. So from day one, you make sure that your information is reliable. Already from your drilling information, the surveyors goes in and stake your boreholes, or normally nowadays your technicians and geologists are experienced enough to use GPS. So we do use survey methods to accurately collect our information. So already you can see we are integrating different sections: survey section, mine planning section. And then what the mine planners would do is that they would then only indicate, block out resources that are economic, and they convert that to reserve. So the output of a resource geologist would be a resource statement, and that is very important to know. And the output of a mine planner would be a reserve statement. And then what they also give to the rest of either the financial department, that's how the finance comes in. The finance would need the life of mine, which would include the life of mine, as well as the medium-term plan, short-term plan. So short-term plan can be your weekly, monthly plans, your production plans, and then medium-term, it's your quarterly production plans, and life of mine can be over your life of mine. Some operation have a life of mine of 10 years, 20, or even for bigger deposits, even longer. So what I've mentioned in the previous section, you see how all these sections, the survey section, the financial section, mine planning, and geology integrate to give out three outputs, which is the resource statement, your reserve statement, your life of mine and production plans. What is not mentioned here is that the exploration department also output, they've got an output which is not listed here, but it's listed on the next section when they are focusing on the geology department. So that is they create news release to sensitize the market and to attract investors to want to invest in your deposit. All right. Now that we know how all these sections integrate with each other, let's focus on geology. So on the top level, these are your inputs. I've highlighted in the previous section, it's your mapping information, your drilling information, and your drilling information, you do geochemical analysis on it, as well as the geotechnical engineers. Already we are introducing another section that works along, that is integrated within the MRM department, which is geotechnical engineering. So they also log the boreholes to determine your rock strength and your structures. And then you also got your geophysical information, be it that it's EM surveys or radiometric logging or density measurements, all these geophysical measurements that get captured during the process. And I highlight that the first thing that auditors do when they come to a site is that they want to verify that is your information reliable. So QA, QC, it's a very, very, very important stage throughout the process. All right. And then once you've collected your data and you've included your QA/QC, you've got procedures in place and you've got your standard referencing material, which is your CRM, you then do a lot of data verification to make sure that does the sampling information talk to your lithology, is the structures aligned, is there certain structures that cut off mineralization. That is where that whole process happens. And again, at the heart of the geology department, you've got 4 key sections. But in this process, so this is not talking to a specific mine, but it's mainly applied to many operations. And at some operations, you've got a grade control section, which is separate. But in this operation, the grade control and the production geology is stated under one department. But then going from left to right, you've got your regional geology, underground geology, which is so these two are your exploration sections. And then you've got the mine production geology section and the geodata section. And all 3 sections do data interpretation at different densities. And then the regional geology section, regional exploration section would locate the resource and do resource definition, and it more or less exactly the same as the underground geology section. The production section here also do stope reconciliation other than the planning of the boreholes, but we'll look into the detailed functions of each section separately. And then geodata is responsible for mainly resource modeling and estimation. And again, just highlighting the key output from the geology department. It's very, very important. The resource statement is a very big component of a geology department. And then for the exploration team, it's the news release and annual exploration reports. Those are the two reports that goes out either to the market or to the rest of the sections, like the financial section, so that they can work out the financial valuation of the project. And as highlighted, survey is from beginning to the very end throughout, and they do all the stope reconciliation, all the stope scans and stope measurements, or pick up benches and all the information. So the survey department is so interlinked and work very close to the geology department. All right. Now, what are the roles of the geoscience department at the mine? Now that we've got an idea how it integrates and what is the key output, but what does it actually do? So the Geoscience and Geology Department is accountable for exploration, resource delineation, resource estimation, grade control, geological mapping, sampling, geological data management, and production geology. Its aim is to ensure that the department explores and mines in a systematic, safe, efficient, cost-effective, and environmentally friendly manner. So again, we bring in another section. Safety is part of the way we operate. It's just a thing with mining is that we want to secure that everybody who comes and work on a mining operation or at an exploration project must go back safe to feed their family and be with their families. So the geology department have got four key sections, which is your resource geology, your exploration, production geology, and grade control. I'm not going to go into the details here because we are now going to start unraveling each section on its own. And I've also explained most of the things when I covered the other slides, but we will go into the details so that it's not repetitive. And this is just a typical structure of how a geoscience department or a geology department is structured. At the very top, you either report to a mineral resource manager or a chief geologist. All right. And then you would have your different section, which is below the mineral resource manager, you would have a senior resource geologist. At some bigger operation, you would even have a senior grade control geologist, a senior production geologist, and a senior exploration mine geologist, and a senior exploration geologist. And then below the senior, you would then find your geologist. Under the resource geologist, you would have a data administrator or a junior resource geologist, and the cycle continues, and where a lot more technical work is, a lot more technical data is collected. You would have technical assistants and geotechnicians assisting the senior production geologist and the production geologist to collect all the information. And then it's quite a lot of work. So most of the sections would normally have a geologist supporting the senior geologist. And regional exploration have got few tasks that need specialized skills, like when you're doing your physical surveys, then you need fixed-term employees to assist you with those surveys. All right, so this is how a typical structure is of a geology department. And then the MRM may report straight to the general manager of the mine, or in other cases, because we are interlinked with other sections, the chief geologist then report to the technical services manager, and the technical services manager reports to the general manager. All right. So now looking at the chief geologist role, what is the role of the chief geologist? A chief geologist manages tasks and performance of the mine geology department, and he or she is a competent person, a specialist to complete annual resource statement, and a technical supervisor of all mine geology functions. And the chief geologist does mentoring and coaching of the geologists, training as well as training, and support and evaluate the performance of the production and plant environments within the scope given. And the functions of a chief geologist would be to translate the company's vision, mission, and strategy into the MRM department strategy. Let's say, for example, the company's vision is that they want to become the best underground operation in the mine, best underground mine in the world. So they would then say that we need to explore and increase our reserves by so many tons, and then that then becomes the responsibility of the chief geologist to ensure that you work out a strategy how you will achieve that mission and vision. So I've highlighted many times that the chief geologist compile or is responsible for the annual resource and at times reserve statement. Something is happening on my screen. Mr. Ino, would you have an idea? All right, those were errors. So I shall continue. The chief geologist also identify and manage geological risk as indicated in the resource and reserve statements. So when we talk about this geological risk, is that sometimes the mineralogy, you may not recover the metals that you want, or at other times it would be geotechnical challenges that you will have. Also, he control and coordinate mine geological functions, including setting the objectives of each section. And he coordinate activities between geology, mining, the business improvement, as well as other stakeholders to ensure optimum use of the resource. And it's important that when you are exploring, you would have different targets. So you need to prioritize those targets for mineralization through the mineralization model. So it's the duty of the chief geologist to prioritize which targets would be worked on during which period. So the scheduling, and it's not or the chief geologist on his own, obviously with the help of the exploration geologist. He established an effective methodology of business operations, communications, and whereabouts status. And control whereby statutory compliance and appropriate mitigation of risk is achieved. And then also important, the safety component, making sure that the ship policies and procedures are updated accordingly. He prepares and controls the section's annual budget by forecasting operational costs and monitoring expenditure and cash flow regularly. So budget is very, very, very important. And already when you get into an operation, even if it's just an exploration project, you get assigned a certain amount of money, and it's important that you never exceed that budget unless there's a justifiable expenditure on that budget. And that's a duty of a chief geologist to control that budget. Okay. And then the resource geologist, the objective of the resource geologist are to validate all data used in modeling and estimation, to produce the resource model, to formulate resource policies and procedures, and to carry out audits and reviews. So the typical functions is data acquisition. The resource geologist is the custodian of your database. All the data that gets collected, your mapping, sampling, drilling, geophysical data ends up in your database, and the responsible person for that database is the resource geologist. He or she does data validation and verification, auditing, QA/QC, geology database management, resource modeling, resource estimation, resource calculations and classification, and manage in smaller operations where you don't have got the IT department set up. The resource geologist will also manage your hardware as well as software requirements for the department. And then in addition, making sure that all policies are in place and everybody adhere to the safety and HR policies. All right, the production geologist, the objectives of the production section is to advise and expertise on the geological aspects of development and production in mine. They oversee drilling, they help to determine likely directions for future development, Production geologists are often responsible for estimating the mine resource, numeracy, and computer literacy, usually from a key part of the job role. So the main function really is to make sure that your exploration, your borehole planning and data is collected, and then they also produce the resource model, the lithological and grade models. So in terms of looking into the details of what functions they actually do, they explore in other ore bodies. Dating or geophysical sampling is part of production geology section, as well as sampling the mineral deposit. And then this is the section that mainly does the interpretation. So they combine your mapping, sampling, and drill hole information and interpret your information on a 2D basis to build your 3D solids. Or nowadays you've got implicit models. So you basically put in after verifying all your information, you plug it into LeapFrog or any other system, and then it creates your lithological or grade models. They prepare and present data during meetings and elsewhere to assess decision making during the operation. They check quality levels of materials produced for resource assessment, and they are also the section responsible for classifying resources with the resource geologist, because they know that this section to that section, we've only drilled a certain drill spacing or drill density. And they assess your, sometimes, not all the times, other smaller operations, you would find that the production geologist will also be able to capture your geotechnical information from your drill information, as well as do water sampling to test the water quality and see if you are contaminating the underground water. And then they update a detailed database. They assist the resource geologists to make sure that the information that they gathered are of great quality. And they create the mine models using computer-aided design softwares. I've mentioned one nowadays. A lot of companies use LeapFrog, and I've got another slide where I'll talk about other softwares used. And then they either do, for underground operation, stope reviews or block reviews, and compile the resource statement. So the senior production geologist is is the person responsible for compiling the resource statement, and the chief geologist oversees that everything is done correctly and the timelines are adhered to. But the actual compilation of the resource statement at times is done by the production geologist. And then the last two is just to make sure that we do not work in silos and in isolation. We are part of a bigger system. So HR and safety policies and any other regulations that are in place must be adhered to. And then the grade control section. The objectives of the grade control section is to monitor the grade of the in-situ ore, the blast ore, stockpile ore, and feed grade, and to reconcile the extracted ore grade. So mainly they monitor the movement of or track the inventory, and also make sure that they feed the correct grade to the plant. In short, the section ensures that during mining, the ore ends up in the correct place. So at mining operations, you've got spotters to monitor that the miners are loading correctly and that they also move the information to the right place. So other digitized operations, obviously you do not have people sitting there, but you've got trucks that are loaded with sensors and they get directed where to go tip. But conventional and old mines, mainly we still have spotters. And then the grade control geologist is responsible for the grade control drill planning and supervision, drill hole data processing and modeling, and they create the lithological and grade model and loading plans. The reason why some of these tasks would be repeated is that at times you would be working at 5 different ore bodies. And if you are only having 2 geologists, then, two production or 1 or 2 production geologists, they need assistance. So at many of the operations, you would find that both the production geologists and resource geologists do create lithology and grade models. but the person responsible for making sure that the QA/QC of these models, or that the models are verified and reliable, is the grade control geologist, making sure that everything gets signed off. Sorry, my apologies, not the grade control geologist, but the resource geologist. So then the grade control geologist is also responsible for ore reconciliation on a monthly basis, a weekly basis. And then they are responsible for making sure that they provide the loading plant, or the loading plans. And also part of the job is to make sure that they acquire quality data. So the rest of the 3 points, it's almost standard for all the 3 sections: QA, QC, HR, and safety. Okay, the exploration geologist. So I'll only discuss the one slide on the exploration mine geology because the functions are mostly repeated, but the roles differ slightly. So in terms of the mine geologist, they are responsible to establish a baseline or background conditions and find the ore body. So at a local scale. They optimize the resource definition and carry out mineralogical and geometallurgical investigations. So that's where you get instructed time and again to cut the core. And it's sometimes very hard when you are remaining with 1/4 of your core, you don't want to give it up. So that's what they are responsible for, metallurgical investigations and writing these ore body reports as well. That's a function of the exploration mine geologist. The aim is to maximize the life of mine mineral resource through integrated interdepartmental functions and processes, implementing risk mitigation strategies, quality, and they do quality assurance and quality checks throughout the process. And very important, they need to be compliant with regulatory bodies like the NI 43101 or either JOC or SAMREC. And they ensure that they ensure optimum use of the resource to maximum metal recovery by using MRM principles that we've identified earlier on. In terms of the specific functions, they identify areas with potential for discovery, and they do surveys, so borehole orientation and radiometric surveys, sampling, geophysics, drilling, test bits, baseline surveys. They compile news releases and exploration reports. And the next slide is the regional exploration. You would see that they do exactly the same, but just at the regional level. So just to reiterate, the role of a regional exploration geologist is to establish baseline background conditions, to find the ore body, to determine ore mineralogy and determine ore resources, to locate areas for infrastructure or operations, to seek to understand the deposits and refine exploration models. So here, in terms of infrastructure, they work hand in hand with the mine planners to indicate, because they are the custodian of where weak zones are. They map structures, and they normally would advise or assist in terms of sharing ideas where best a certain infrastructure can be built. But other than that, the regional geologist and the mine geologist more or less have got the same functions. Okay, now we've covered a whole lot of theory. I hope everybody's still on and nobody's sleeping. But let's get into the more exciting things. What is a typical career path for a geoscientist at a conventional mining operation? So once you graduate, you finish your geology degree, you would be assigned to either an exploration company or a mining company, and you would become a professional in training, which is called a graduate trainee or a professional in training. At our operation, we call them PITs, for professional in training, and normally the program would be 2 to 3 years. The idea with this program is that you get an opportunity to be exposed to all the departments across the value chain. So you get to spend 6 months in the production section, 6 months in grade control, mine geology, exploration geology, and not only do you spend time within the geology department, you also spend obviously less time, but you get to spend time with the planners, the surveyors, and it's so important that you do that, because when you request a task, you need to know what is the process, and when the other departments raise concerns or challenges that they are facing, it's just easier once you know the whole value chain and how the processes are. So the PIT would take you 2 to 3 years. If you are lucky, mainly 2 years, and then you've got a very good foundation. This is a very critical step. And even when you look for employment after completing your degree, you need to ask the right question. Ask that institution that is hiring you, do you have a graduate trainee program? Because if you've got that, you would have a very strong foundation, and already you would be a step ahead, because you would understand the whole value chain from the word go. So this is very important. During your interview, please do ask the question, do you have a PIT program, and how long is your PIT program? Because you don't want to be on a PIT program for 5 years. By 5 years, you should be an independent geologist working, and make sure that you allocate your time correctly. Don't get drawn into carrying mainly just sampling or so for 5 years. Don't do that. It's going to kill your career and you won't advance. So make sure that you've got a valid PIT program, well defined with timelines to it. So that is your step one after finishing your degree. It's a professional in training. Step two is then once you've acquired all the experience and you now can more or less work independently as a geologist, you then get appointed as a mine geologist. And when you get appointed as a mine geologist, you can be appointed in the sections that we've discussed. So you either become a grade control geologist, a production geologist, a mine exploration geologist, or a regional geologist, a regional exploration geologist. But the point here is that within 3 to 5 years, you should be able to work independently. And as a mine geologist, you would be reporting to a senior mine geologist, and your task will be to plan, execute tasks, to do QA/QC, and draft procedures. Make sure that you do your planned task observations, because you would have already assistants working for you or under you, and you would already be exposed to supervisory skills or leadership skills, because you would be now leading a group of smaller group of assistants. So that is your 5 years. If you are not there, ask yourself what went wrong, how can you rectify, who can assist you. But within 5 years, you should be able to work independently as a mine geologist. And thereafter, step number 3, once you've gained 5 years experience, because then you can already sign up as a professional geologist. So within 5 years, you need to be promoted to a senior mine geologist. And that would take you about in 3 years to become a competent, at least 3 years, but another 5 years to become a competent senior mine geologist. By then you really manage other professionals, and it's a different story when you are managing professionals. So as a senior mine geologist, you would be reporting to the chief geologist, and you'll be responsible for your section, and you would have junior professional and assistants reporting to you. So already you've got a bigger group reporting to you, and you are responsible for producing your monthly report, your quarterly report, as well as your annual reports. And you may get reassigned to other projects to gain more experience. For example, if your company would like to now do EM survey and you need to implement that survey, you may be assigned to another operation to acquire those skills. And you may also be recruited if you become a very good at what you do. If you become a very good research geologist, you may be seen by the corporate office and already be drawn into corporate roles. And there are three things that you need to remember that is very critical that most employers look for is competency, character, and culture. You need to acquire competency. Once you've selected that, because as a PIT, you will be exposed to all the different sections. And by that time, you should know this is where I want to be. I want to become an exploration geologist, or my passion is with resource modeling, or my passion is estimation, and make sure that you become competent in that field that you choose. And character is very important. Look at the company culture. And if the culture is not a very bad culture, make sure that you align yourself to it. Otherwise, if it's a bad culture that allows you to spice or put in gold into your samples so that you can get investors, get out of there. It's just going to ruin your career. But it's very important. If the company, for example, have got teamwork, so as one of the values, you need to align to that, and you need to know that if you work solo, you won't fit in quite well. So that is very important that you assess your character, and then culture and character goes hand in hand. All right, so that's stage number 3. That should take you about 8, maximum 10 years to be a senior mine geologist. Stage number 4, you now have got, you've acquired 8 to 10 years within your field. There are only few options. You either become a specialist, and I'm mentioning these 3 areas that I haven't mentioned, but as a geologist, the bad news is that you may love geology so much, but there is evolution. Your whole career evolved. You may not get stuck with geology unless you plan to become a specialist or you go into research. You will be either drawn into management, or you can also move into other areas like a most geotechnical engineers are either mining engineers or geologists or chemists or physicists by profession, but they just acquire additional competency. They either do a master's in geotechnical engineering, and then you can become a geotechnical engineer. And it's a very lucrative career. It's just that it's not, I haven't included it in this discussion because we are looking at mainly geologists from a geologist point of view, but I'm highlighting that that is an option as well. So you just need to acquire more academic skills. So you can either do competency certificate, a geotechnical competency, advanced competency certificate, but it's not done in Namibia. Unfortunately, you'll have to do that with a South African institution. Next time I'll prepare better for that, but otherwise it's a master's degree in geotechnical engineering or rock mechanic. And then you can either move into mine planning. So again, for that, as a geologist, if you want to become a scheduler, all you need to do is just a basic mining course, and as you learn a scheduling software. So those are options that you can go to become a specialist, either a resource geologist or a specialist in terms of exploration geologist, and that is all you want to do. Or you can go into geotech or mine planning. And there's also within my career, I've seen people who move from geology into operations. So then you go into becoming operations manager or a mine manager. And for you to do that, you need to get a blasting certificate, and to really have a good base. Not only do you need a legal background, you also need to have a mine overseer certificate, which is also only obtained in South Africa, but it is an option. So this is after 10 years. And as a specialist or a geotechnical engineer, you will be reporting now to the technical services manager, and you would sign off as competent person, and you would be able to produce life of mine, geotechnical and geotechnical or resource statements and reserve statements. So that is stage 4 of your career. Stage 5, it's where you now become either a MRM manager, technical services manager, production manager, or a planning superintendent. So that is, if obviously you would need more than 10 years. and you would be reporting straight to the general manager or the group manager or the mining manager. And you will be managing your department. You'll be signing off as a competent person. You would deliver resource statements, reserves, life of mine, and achieve production targets if you go into operation and become a production manager, but it is an option. All right, we can get back to the slide if you've got questions, but this is really the heart of the presentation. It's a career path for a geologist. These are the options that you have. I didn't mention one here, which is you can go into mine evaluations, but then again, you also need additional studies into financial evaluations of mining projects, but it is an option. All right, but what are the critical skills and knowledge that you will require to perform well as a geoscientist at a mine? So what is it that you need? This is not even to set you apart from the rest. It's just to be able to do your job and do your job well. You need database knowledge. You need computer literacy in terms of 3D modeling and estimations. Or for exploration geologists, you would need to use your ArcGIS or your Leapfrog. And then computer literacy, nowadays everything is going digital, so you need to acquaint yourself with computer skills. Make sure that you learn your computer skills. And then the softwares that are out there in the market, it's a must. You must know one of these softwares. Otherwise, nowadays, you won't be able to operate well as a geologist, because we are moving away from papers and we are becoming, the world is just becoming highly digital. All the information is now digitally collected. And if you remain old-fashioned, nobody's going to employ you because you won't be able to do your job. But in terms of the softwares, there's a MineSite, DataMine, MicroMine, Deswik, and Vulcan. That's what I've been exposed to, but obviously there's a lot more. Rushpina Mine uses quite a couple of them, but we are at mainly MineRP and Deswik. I didn't mention MineRP here. But there is quite a lot of software in the market, and it's important that if you get to a new operation, learn the software. Nowadays, you cannot be a geologist and not be digitally transformed. You need to transform with the era. And then 3D conceptual thinking, it's very important because you would do 2D sections, interpretations, and you need to visualize your ore body in 3D. So I've mentioned that. All right. And then there's also other soft competencies. If you can do the rest, if you can work on your own. So literally those skills and knowledge, you would be able to work and produce work. But then I've mentioned that we do not work in silos. So what are those competencies that will enable you to perform well as a geoscientist? Important, you need to have a drive for results. You cannot just be mapping, and you do not produce that map. At the end of the day, you need a map. If you are sampling, you need those essays plotted on a map and anomalies highlighted. Those are results. You need actual results. Don't just do work for the sake of doing work. You must get results out of it. Communication is very, 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 very important. I've seen a lot of people in my career who are technically very good, but they haven't worked on their communication skills, and as a result, they stay frozen at one level for very long and they cannot advance to the next level. So invest in yourself. Take that English course, or if it's a French company that you are working for, make sure put in the effort to learn how you communicate. And communication is not just only verbal; it's a written communication. Please, your writing skills. You need to write. Make sure that your reports that you produce is it's a report that anybody, even a non-geologist, can take and read and understand what you wrote. So, and then another skill is analyzing data and information. That is becoming the core, because nowadays digitization, it's key. So you've got a lot of data coming in and you need to learn how to analyze those data. Very, very, very important. Information search. If you sit behind your desk and waiting for information to get to you, Nobody will bring you the information, so you will be sitting there and again remaining at the same place. So go out there, be proactive, volunteer yourself, and look for information that you need in order to achieve your objective. So you need to gather your information. And management, very important. So management, the basic planning, organizing, controlling, that those management skills are very, very, very critical. You need to just have the basics in place. Without that, you won't manage. Time is a limited resource, and you need to manage it very well. And then another one is problem solving. And I've mentioned that we also do not work in silos, so you need to be able to work with other people. So your client service orientation, and in terms of the client service orientation, I'm not speaking about external clients. I'm talking about your the resource geologist. The client can be the production geologist, and you need to work with the production geologist very well. And then relationship building and networking, it's very, very, very important. It's so key for your growth. It cannot be emphasized any different. So you need to, because you don't know what you don't know. And the only way you would know things is if you engage people, if you hear from others, or how, pick up the phone, call, or write an email. How are you doing this at your operation? Can I come and visit your operation? So you need to network and know who to call when you are stuck. All right. If I may find out, how are we doing with time?
We are good with timers. You can keep going.
All right. So I've covered a lot of theory, and now I'm going to share with you. It's always nice to cover the theory, but it gets stuck in your head when you can see that somebody went through the process and where are they, and maybe during the questions we can discuss what were the challenges and things like this. But as you can see, I've had quite a very colorful journey. I've been very flexible. If they send me to the field, I went to the field. So if they wanted me to, or if the company wanted me to wear a suit, I would dress a suit and represent the company with pride. And I always enjoy what I do, even if it's just sampling. Even I remember Dr. Mapani visiting Roshpina mine, and I was still a senior production geologist, and I was still logging coal. And that was, I think, after 8 years. And Dr. Mapani asked me, Sheron, are you still logging coal? I'm like, yes, Dr. Mapani, I'm a senior production geologist. And I'm still logging coal. So it's also very important that you do not forget the basics. And time and again, because you need to assess and verify information. So don't just get, once you get to the next stage, forget about the rest. You need to know how processes are evolved, because things are evolving, they don't stay static, and you need to get involved. So that is my journey. I'll share with you in terms of experience, just filling in the gap and highlighting what were the highlights at the specific stage of my life, and then also just share a little bit about my qualification. Not more in detail, I think it was mentioned quite well by Mr. Eno. But yeah, in terms of work experience, so I studied at the UNAM, and my first job was after finishing my BSc geology. I did BSc geology and environmental biology, and I did not go for further studies because by then UNAM didn't have the honors degree. So I went straight and worked for Scorpion, who were, I was a bursary student with them from 2002 to 2004. So I worked as a graduate geologist. And one of the exciting things that, other than the geotechnical work that I did in terms of testing the rock strength of carbonates in the pit, I drilled, it was actually my first exposure of exploration drilling, and I did bedrock drilling, and that drilling is what picked up the Gerkarup anomaly, and then further work with squid analysis and squid survey and more drilling led to the discovery of Gerkarup. And based on this drilling program, I was immediately, I don't think I stayed long. I only drilled for 6 months, and a position was then available as a mine geologist. And I was the lucky one. I was recruited as a exploration, or mainly I went to Langerheinrich as an exploration geologist, but I used the term mine geologist because at most of the operations that I worked, I've been exposed to all the different sections. So then the term mine geology would mean that I was all over the show, but I'll share with you what I did exactly at Langerheinrich. So at Skopje, I only spent a year after graduating, and then I joined Langerheinrich, and I was the exploration geologist. And I should say that I lived at Langerheinrich for 3 years in a tent, enjoying my biltong and my savanna light. And I drilled that resource from group intersection or historical information and converted the resource into inferred, indicated, and then I did the measured drilling for pit A, which was the first pit. So this was really one of my good exposure, or the best exposure I've had, because I was exposed to all the different sections. I was for a very long time the only geologist. So I would mainly carry the whole process, do exploration. Once I collect the information, I would then estimate. And I also did grade control. And I did production geology in terms of marking out the blocks that would be mine. So that was a very good 3 years of my life. And thereafter, Langerheinrich, I moved to Trekopje Uranium Project. And again, nothing new at Trekopje. I did exactly what I did at Langerheinrich, inferred to measured, and then just strengthen my resource estimation skills. That is one good thing that I did at Trekopje. And I independently produced, because Langerheinrich project, you just estimate within a space. You don't create lithological and create model. So at Trekopje, I was able to use 2D sections and build 3D solids. So that is my first great and lithological modeling experience, and I worked there until 2010, and then the whole project was put on care and maintenance after the Fukushima incident. So at that time I was still young and enjoying myself, and I thought I could do it. By then I already had my two, my boy and girl, the first two children. I've got three. So last one is 10 years old. But I thought I could move the world. So I went and opened my own consultancy, and I rendered service for Trekopje, again, just continuing with my modeling work. But other than that, a highlight for the geological services, my company that I created, I compiled a technical report for the Narugas Iron Project. It's now a brownfield project, but investment is a problem, so it haven't flourished into a mine. I would actually like to see that flourishing into a mine. And I only did that for 1 year, and then I realized that the children need their mother and I needed stability. So after a year of working and ad hoc income, that was another challenge I faced as a principal consultant. I wasn't getting money every month, so things were piling up. And then I applied for the senior production role at Roshpina Zinc Mine, and I got the job. And ever since I've been with Roshpina Mine. So from 2012 to 2015, I was a senior production geologist. And I should say that it was fun for me to compile a whole resource statement by myself and sign off as a competent person for resource compilation. That is something I used to enjoy quite a lot, and I took pride in that. When auditors come, they would obviously audit my work and work very close to me. And other than that, I think Roshpina Roshpina Mine really exposes the graduates to almost the entire section. As I've mentioned, even though I was a senior production geologist, I could do almost everything. Okay, I was also a senior production geologist there. I was not directly, but I was working close with the resource geologists, production geologists, and grade control. I literally did the work. If a senior geologist goes on leave, I would be able to step in and comfortably do the work or stand in for them. So that was great exposure as well. And after 2014, Roshpina Mine got sold to Glencore. And by then, I was quite strong on my resource estimation because I've acquired now, 2 qualifications in, by that time. First, I just had my GDE, but great experience with resource estimation, and they recognize that I'm quite good with geostatistics. So they appointed me as a mineral resource manager, and I was a mineral resource manager until I think 8 months ago. Again, they saw potential in me in terms of management skills, because once I tick off that I've acquired that skill, I always move on to the next skill, identify what is that next position, and try to acquire those skills. So I'm quite flexible in terms of working with people. I treat people very well, and that is one of the qualities that they really like about me. So, but this was now Travali. So 8 months ago, when the technical services manager left Roshpina, I was then again given the technical services manager role. And it was a very painful experience, I should say, because my whole life long, so it's almost a whole 10-year career of geology, nothing else. And now I was given the responsibility of learning survey, geotechnical engineering, geotech, mine planning, and ventilation. And it sounded like Greek, but I actually started enjoying knowing other fields and how they all fit together. That was fun. So one of the highlights for me as an MRM manager, when I took over the life of mine was 7 years, and currently Roshpina Mine has 11-year life of mine based on indicated and measured resource, but a potential life of mine of almost 20 years. So I managed to increase the life of mine with 4 years and increase the total resource with 7 million tons, which is quite significant. And also I was part of the digital transformation. I was part on, or I won't say that I implemented them, but I was part of the team that implemented and fully adopted Leapfrog, this week, MineRP, digital platforms on the mine. So if you go to our operation, we are almost going paperless. We've got all this softwares. And about 3 months ago, I was again looking at my management skills and probably ability to adapt very easily. I was recognized by the financial manager to be a good fit for an understudy of the vice president operation. So currently I'm the vice president, an understudy to the vice president operation for Roshpina Zinc Mine, and I'm getting very good exposure in terms of learning more on stakeholder engagement, financial funding, and a lot of good things. And I'm really enjoying being an understudy and still doing my work as a technical services manager. And I'm also, as highlighted, the president of the Future Leaders Association. And the next slide, I'll cover a little bit of my qualifications, but the moment that I finished my finance course, MBA finance course, I was appointed to be a representative of the Roshpina Mine Pension Fund. That is again very fun, going into finances. So that is the evolution that I spoke about. You love geology, but the truth is that you may not end up in geology. And again, if you do end up in geology, unless you really, really love what you do and you won't get bored, by all means, you can remain an exploration geologist. But that is exciting because it's always a new borehole, new information, and some people are excited by that. But for me, I like taking on very big challenges, things that I don't know, and try to find out what is it all about. So I do get bored if I stay in one position for too long. So it has been a very exciting journey, and I'm still continuing to enjoy my time with Roshpina Mine. Okay, so in terms of qualifications, I've indicated that I did my first degree with UNAM, the University of Namibia, 2001 and 2004, and I was the best final year geology student for 2004. I remember getting not really my first check, but I've had another check when I was one of the top 10 learners at Vanidub. It was also a check of 5,000, but this was when I received that award. I also got a check, and it was really nice, enjoying that good money. But I should say that my first degree, it was really good in terms of installing the foundation. But when I went and did my honors at Rhodes University, it was a different ball game. For the first time in my life, I started getting 50s. Even it didn't help how hard I tried. I even cried in the toilet. It didn't help. The fact that I moved from a theory-based to a research-based university, and I didn't have the skills. So in 2009, I had serious challenges with my degree. For the first two terms, the highest I would go was a 58, 55. That was the area I played in until I learned how to read scientific papers. That is the key. And you needed to do research. That's why, again, as a geologist, information gathering is very important. And you need to learn how to read scientific papers to be able to do postgraduate qualification. So, and also the other thing I think that played a role with me is that I went to work. You can see the gap from 2004. So I stayed almost 5 years with no studies. So getting back into studying was a challenge, but I managed to graduate, and I acquired all the skills required for postgraduate qualification. And I decided while the iron is still hot, I went on and did a postgraduate diploma in mining engineering, specializing in mainly MRM or resource estimation. And I aced that. By then I knew how to gather my information. I knew how to prepare for an exam on like a theory-based exam, because there you only get the skeleton and you need to put the meat yourself. Otherwise, if you present the skeleton, the most you will get is probably a 40 or 45. So in 2010, I did my postgraduate diploma and got a distinction. And then I went to Roshpina, and most of the studies, I never paid for any of my studies. So BSc honors, I've indicated it was Scorpion Zinc. No, my BSc degree was Scorpion. BSc honors was Tracopia that paid my studies, and I was doing block release. And the graduate diploma, I had a partial bursary, and I think, yeah, no, it was still Tracopia. I think so. But I had a partial bursary. I had to pay some of the like accommodation and transport. I paid myself, but they paid the tuition fees. And but by then I was already I was identified as a research geologist, so they supported the study. So Telecopia paid for 2 of the degrees, and then my Masters of Engineering, I also had support from Roshpina Zinc Mine, and the MBA, I'm happy to report that my MBA is fully funded by Roshpina Zinc Mine, and it's still part of my development program. And I did my MBA, I just completed like a month ago, and the Future Leaders Association, it's actually my it's my MBA project, and a very exciting journey. Willing to share with the rest of the team. So that is this year MBA, my master's in engineering, still specializing in mineral resource management. Completed that in 2018. I was hoping to do a PhD, but unfortunately I need to delay those plans because I now have got a bigger challenge to be able to operate as a vice president or a general manager of a mining operation, and I'm on an accelerated program. So I need to invest most of my time into making sure that I acquire all the skills required. Thank you so much. That was a mouthful, but please do feel free. We can go step back to the slides if need be. I'm willing to answer most of the questions that the panel has.
Thank you so much for the amazing presentation, Miss. It was very informative and positive. We all learned something new.
Thanks. You know, I forgot to mention that at the beginning of the presentation, I was, you can see the picture, it's hard, I'm nervous, no smile, but at least now that it's over, I'm smiling and still looking at the same call.
Indeed, indeed. So now we've reached the question.
Yeah.
So now we've reached the question portion of the presentation. To make things go smoothly, anyone with a question for Ms. Sheron should please use the reaction button at the bottom of Zoom to raise their hands so that the questions can be delegated to her in a prepared order. And if you don't feel comfortable asking it verbally, you can also ask your question in the chat box below.
I think there's a slide that we skipped. I don't know how that slide disappeared. There's a conclusion slide. Do I still have control?
Yes, you do.
Why can't I go back? Huh, it decided, there it is. How come? Okay, let me, in the absence of questions, I can go through the slide because it's just covering everything I've covered in some few tips for everybody. So the key thing here is that you need to plan your career path. As I've mentioned, 10 years, 15 years from now on, you may not be a geologist. You can be drawn into different areas. And if you've got a passion, as I've highlighted, that if you want to be an exploration geologist, by all means do that. But then still, it does not say that you don't need to plan your career path because you want to become the best exploration geologist probably in the world. So you need to look at that job profile and identify the key skills that have been listed as skills and knowledge required for you to perform, and tick them off. Do I got everything that is required for me to operate in that position? But how I went about my career is that I didn't look 5 years, 4 years. I always look what is the next level, and then I would look at the job profile and identify that and make sure that I tick that the skills and knowledge required. And very important, I highlighted the 3 C's, which is competency, culture, and character. It's very good being polite, asking correctly, and raising your voice, obviously asking the questions, but you need to align your characters to the culture of the company that you operate in, and you need to gain competency in terms of soft skills and hard skills, technical and communication skills, writing skills, data analysis, and don't be shy to just avail yourself. Be seen, but not by doing simple things. Like the quality of your work should make you visible. That's what I mean by that. And time management is very important. Make good use of that limited resource and elevate your career. If you make good use of your time, 8 hours of the day, I always have got this philosophy that I would never go to work for 8 hours and do nothing and get paid. No. So I make sure that my 8 hours that I'm at work, I'm very productive. By the time I enter that office, I know exactly what I'll be doing and how long that specific task will take me, and what are the things that needs to be resolved for that specific day. So time management is very, very important. And you need to create networks and commit. Once you commit to give somebody something, it's very important. Make sure that you deliver that report on time. Ask questions if you don't know, and show up. These are important evenings, so just show up. You will learn even a single thing or two. So show up, be present, ask questions, very important. And then the one thing that really have helped me advance my career so much, it's having good mentors. So I've had a couple of mentors, not only one, but all of them. You would have regular feedback that, no, Sharon, here you are lacking. This is constructive feedback. You don't do this right. So that is very important. Find your mentor, and then in other cases you may need a coach. And be proactive. Mentors don't have time, so be proactive. Reach out, say, look at this report, what do you think, Sharon? And then the other thing is that deliver quality results, as I've mentioned. Let your work speak for you. Yeah, so excellence should become, even if it's just sampling, making sure that you do not contaminate that sample, that when people do your QAQC, there is no outliers. It's as simple as that. Every task that you do it well. And that is the one of the things that would set you apart from the rest of the people. And well, finally, enjoy your geoscience career. It's exciting. It's like a roller coaster, up and down, but it's what makes it exciting. Mining, it's not easy. It's very challenging, but it's an exciting career. I wouldn't do anything else than what I'm doing.
Okay, thank you so much, Mas. We have one question for you here. It's from Cassius. He's asking if one can become a geology assistant as a student.
Sure. But is it during vacation or? Okay, but I'm so sure that the person won't be able to reply. Definitely, you can. The thing is that sometimes the market is so saturated, and then geology jobs are not available. So what we do is that we advertise for geological assistants. Please do grab those positions if you do not have a job yet and you are qualified geologist. What we then do, once you get into the system, we identify your talent. You would understand. So I can proudly say that we've taken two students, and they came in as technical assistants, and today one is becoming a resource geologist, the other one just moved into a grade control assistant, and we are training Donovan to become a production geologist. So it's a great way to get into the system, but do not get stuck there because you are qualified. Just it's a good entry point, but do not get stuck there. But please do. And especially if you don't have experience, it's one of the things that you can do, because geological assistants also do exciting things. They do core recovery, sampling, most of the work that you would understand. And what normally happens is that when a lot of drilling is being done, um, then geologists may not have the time. And if you are a geologist, they then train you to do lock core hole, to lock the core. That's how you then get into becoming the geologist that you want to be.
All right, thank you. And another question. Tulonga Hidipo is asking, how is it that you have found GIS specialists, cartographers per se, valuable to the mining sector?
Come again,
How is it that you found GIS specialists valuable to the mining sector? Yes, that's the question.
I think the answer is that exploration geologists, all the database is a GIS. And for you to get the maximum value out of it, you need a GIS specialist to manage it. And even a GIS is so intense when you do advance. For geologists, obviously, overlaying a few maps, it's easy. But when it gets into the background, making sure that the health checks and all those very difficult tasks, you need a GIS specialist. So in that light, they are valuable in terms of maximizing the value you can get out of your GIS program.
All right, thank you. And Rosalia Shimi raised her hand. It appears she has a question as well.
Sure.
Hello, Ms. Sharon. Thank you very much for the great and very informative presentation. And it is refreshing to see a woman in such a big leadership role in the mining industry. Just a quick one. What advice do you have for young female leaders who are aspiring to get to your level? And what advice do you have for them in navigating the male-dominated industry?
You know, did you get the question? Can you rephrase that?
I'm sorry, I didn't quite hear that.
Hello?
So I think if I can try to see if I've captured that correctly, it's what advice do I have for a female who aspires to get to the level that I have? I would refer the females to the last slide. That slide is very, very important. The advice that I have is that you need to really plan your career path and find somebody who would encourage you. That is a mentor. So mentorship and networking becomes very, very, very critical to your career advancement. If you do not have somebody who's motivating you, because as a female, I've been there, as I've mentioned that I took a 5-year gap, no studying, no, even though I was performing well in my job, but obviously sometimes you need to add a few, continuous studying is very, very important, but so is job experience. But even within your job experience, if you are not learning things that would put you, like make you versatile so that you can get advanced into the next level, you will remain in that same position. If you go to your job, you log boreholes and that is all you do, and you do not acquire any other skills, you will remain there. And I've seen people in my career who have 20-30 years experience in just grade control assistant or grade control geotechnician. But mind you, it's 30 years. So what could you have done in those 30 years to move to get you into even becoming the next mine manager? So the difference there is that you need somebody to support you. And we've got now, I think we are quite flexible, that we've got quite multiple associations assisting ladies, and one being us Visual Leaders Association. We want to support, make sure that if female, even if it's time for you to start to start your family, you should have sufficient support to still continue with your career. Nothing should stand in your way. You should be comfortably doing what you need to do to get to the next stage. So I'm willing, I will definitely share the presentation with SEC, and people can get the presentation and with time go through the presentation and ask questions. But very important to have a mentor to develop competency and just know which is the next level that you want to be in, and make sure that you acquire those skills. And don't forget the soft skills: management, communication, writing skills, data analysis, very important.
Thank you, Mas. Thank you. And the next question comes from George, who's asking, what is the difference between a mine geologist and a production geologist?
In this case, normally mine geologists, you basically do all the functions. A production geologist, it means that you are responsible for production drilling, infill drilling, and managing your inventory in terms of where the run of mine tons goes. But mine geology, you can be a mine geologist and you do estimation. It's a loose term used for any of those departments. So as I've mentioned, I've used mine geologist because in all the operations that I've worked for, I've never stick to I never stick to one section. I mainly operated in all the sections from grade control, exploration, research. So the best term to describe what I was doing is that I was a mine geologist.
Okay, thank you, Miss. And I see that Vanessa raised her hand. So she has the next question.
Thank you, Eno, for the floor. Ms. Sharon, I have a couple questions. The first one is I would like to know which fields right now in geology are over and under saturated. And also the other question is when you were describing the chief geologist, yes, you mentioned several characteristics of a project manager. So I would like to know whether to be a chief geologist, you have to be, or you have to have the qualifications of a project manager, or simply just the characteristics in this case.
All right. So it's two questions. Which one was? Okay, which jobs are saturated and which are not? Let me start with that. I think because but it's a global world. So I'm the type, based on statistics, they say that the market, there is growth. So if you look at it from that angle, there isn't such a thing as oversaturated. It's just how do you get yourself to become a global citizen so that you can get the job elsewhere? Because I've attended a few conferences and elsewhere, the number of geologists that are graduating are few and the jobs are available. But in our case, we've got more geologists graduating and only limited mines. So in terms of being a global citizen, there is no saturation. But locally, I think I would, most of the mine geology sections are really saturated. That's why in my presentation, I spoke about fields like geotechnical engineers, those surveyors. If you want, you can go into being a surveyor. Chief surveyors are equally remunerated as well. So mine planners, they are limited. That's why I've mentioned a resource geologist, like who do estimations, very, very few. I only know a handful of us. But if you get to exploration, production, grade control, those are jobs that are mainly very saturated in my view, but I may be wrong. But I know that geotechnical engineers, mine planners, surveys, all, and then the resource geology, it's one of the very rare fields, rare vacancies that are still available and not so saturated. And there was a second question, project management. I think at that level, you don't need the qualification. If you've got experience, you should be able to manage a project, because already at a mine geology level, you are managing a drilling project, and it's the same principles that you apply when you are just doing it at a bigger scale. So it's not necessarily that you need to have project management, but if you do have it, it's an advantage.
All right, thank you, Miss.
All right.
Our next question comes from Sunny Shilongo, who asks, where did you get your bursary from? And how would you advise younger people on how to get jobs?
So bursaries, the only bursary that I got while I was outside the institution was Scorpion. And how I got that is that they came to UNAM and they interviewed a couple of us. And as you've seen, that I was the best geology, the best final year student. So that was automatically, I was selected for that bursary. So other than that, I work for companies, and the last slide again to say that you need to ask. You see, most of us do not get things because we do not ask, we do not negotiate, we do not raise our hands. So it's just asking the company. The worst thing that people can say is no, and no won't kill you. So it's just going to your supervisor, and you've been working for this company for 2 years, and you have a discussion to say, listen, Mr. X, I need to get to this next level and I need this qualification. And some companies even have got study loans and study assistance for the employees available. Then you can qualify for that, and you can continue studying, because nowadays things are in any case online qualifications, especially your postgraduate qualification. Do it online, use study assistance from the company that you are working for.
All right, thank you for that, Mas. Please be patient because we still have a few more questions lined up here.
Oh, and time-wise, how are we doing?
Time is looking good. Time is looking good.
I'm at somebody's office, and I'm just mindful that they may want to close.
Oh, we'll conclude soon. We'll conclude
All right.
soon. These are the last two questions.
All right.
So Fred asks, with the life expectancy of the mining industry degrading every single year, what advice can you give to someone who wants to major in mining? This is because some relatives discourage us that there is no future in the mining industry in Namibia. What do you think of this assumption?
Again, I will point out to that with technology and globalization, we are now one big global family, and there are still a lot of areas that are underexplored, even in Namibia itself. So it's just that the current mines may reach their lives, but new ones will be discovered. And if you look at, for example, a country like Angola, they've only been looking at oil and diamond. All the other sectors are booming now, and they've got no expertise. Why are we sitting with our degrees here in Namibia when there are jobs out there? So I would advise that we start looking at, we start exporting skills, because we are really graduating a lot of geologists and mining engineers. It's high time that we allow ourselves to get that international exposure.
All right, thank you for that. Thank you. And our last question comes from Sam, who asks, do you see a future where zinc is not just being sent out of the country, but is instead being used here to uplift the economy?
Definitely, the answer is yes, I see a future. There's obviously things in place that can enable that, but it needs to make economic sense. So with all parties working together, I would say that yes, it is a possibility. It can happen, but it needs stakeholders to work together and make it happen. The floor is yours.
All right, thank you, Maz. One last question from Winnie. She asks if it's possible to become a mining or process geotechnician as a geochemistry graduate.
Come again?
She's asking if it's possible to become a mining or process geotechnician as a geochemistry graduate.
Chemistry graduate. I think the answer is yes. Literally, because I've seen somebody who did that, but the bad news is that they had to add on another qualification, which is the competency certificate in rock mechanic, for them to get into these fields. So you may need additional work to get in. but there is a new field. I don't have much information about it, but people talk a lot about nowadays about geometallurgy, and one institution in Ireland is offering that, I think. So that is something that I can explore, that the person must just search on geometallurgy. And hopefully you can maybe do few courses to become a geometallurgist, and you can either work as a production geologist or a metallurgist at the plant, but looking at the type of ore that we feed and the characteristics of that ore.
Okay, thank you so much, Mas. Those are all the questions we'll have for
All
this
right.
presentation. I'd just like to say thank you again for finding time in your schedule to present on such an important topic to us.
Okay, it's my
And
pleasure.
then I'd also like to give out some thank you remarks to you, the SEG, the UGSS, and to UNAM for sponsoring this yet again. And with that, I believe we can end this meeting on a high note.
Thank you so much, everyone. It was a great session, and please, I'm open for feedback. I always want to become better at what I do. So my email is skaviua@gmail.com for further questions or for feedback. So please do reach out. Thank you so much, Ino, and the rest of the team.
All right, Mas. Thank you. Have a good day, everyone.
And I quit.
Ino, I see you are still logged on. Just a question, do you perhaps record the session?
No, I wasn't recording, but our president was.
All right.
Yes.
Yes, I'll send you the
Share the link?
presentation after it's done downloading.
All right.
All right.
Should I email the presentation to you?
Yes, that would be great. That would be great.
All right. Thank you so
very
much.
much. Thank you. Bye.
All right. Thank you. Bye.